Hai, Assalamualaikum warahmatullahi wabarakatuh. My name is Mahaziz bin NORSHAM. I'm from BEI 1/2 4th year student in University Technical Malaysia Melaka. Today, I will introduce to you about my project on development on the smart trolley with analysis of battery. That will consist my Raspberry Pi, Arduino, and my main analysis for the project is the difference between two types of battery, that is lithium ion and lithium polymer. That is, which of this battery will be more efficient and good in long lasting of the smart trolley functioning. It will consist of two programming. This is one for the barcode and two for the infrared sensor to avoid the obstacle that will be in our way when use the smart trolley. Okay, this is my poster for my project in final year. As we can see, in this poster, we have input on the project background, the introduction, the project objective, the problem statement, the analysis, the methodology, and lastly, the conclusion and recommendation. First of all, we can see about the project background. The project will be used as a trolley that can detect any barrier or distraction by lighting up the LED that will be placed on the trolley. The LED that we will use is a normal LED that we can get, and the infrared sensor that we be connect to the LED is about 3 infrared sensor. So this is will can help to detect it more on the area. So the trolley consists of Raspberry Pi that used to scan the item price by scanning the barcode. This will can help our user to manage their budget based on they can input their budget price for their spend. Smart trolley, I will discussing about how this smart trolley can be used in long term, even though we know we can use any compact battery, or we can say as easy way to bring the battery as a power bank. And in this our era, there are a lot of type of battery that can be used, but in my project, I will make analysis on two type of power bank. That is lithium ion battery and lithium polymer battery. My project objective first to make an analysis on different type of battery, to develop the smart trolley for shopping grocery, to evaluate the long lasting and discharging between those battery lithium ion and lithium polymer. My problem statement. Now there are a lot of technology that used today. So as we can see, somehow we want to use the gadget, the product as long as we can, and also can ease our way to use it. By when there are long lasting products, we can take our time. There's no need to make a long time to change the maintenance of the battery repeatedly. So by this analysis, we can know between lithium ion and lithium polymer which is better for last lasting. We will go to our analysis. This is my graph on lithium ion versus lithium polymer data that I have used about 6 hour range. 6 hour range because as I mentioned, our trolley will be used about 6 to 9 hours per day, then 12 hours of shopping mall opening. So when we can make this product on our shopping mall, there will be a lot of trolley and our customer can use it. So after the analysis, I can show you that the blue color is the average lithium polymer and the red color is the average lithium ion data. So by this graph, we can see the increasing of the data indicate that the process of the power bank discharging shows the smart trolley will consume the power source from battery. So based on the graph, the lithium ion will be discharged more than the lithium polymer power bank. After about 6 hours of data collect, the ion is more likely easy to discharge than the lithium polymer. It affects the efficiency of converting power for the smart trolley quite well as for a long-lasting usage. The results show that the lithium polymer is better usage. This is due the power is reduced. The charging again the power make it more faster charging to operate again. So that's my analysis on the lithium ion lithium polymer. So on the behalf, after the 6 hour of analysis, I can see the lithium ion and lithium polymer quite have a lot different things, such as the weight of the battery itself, the power of discharging, as the milliampere per hour, and of course after I open up the power bank, actually the power bank have a regulator to make sure the output from the power bank is 5 volt, that can what we can say suitable for the small gadget. But actually from the pack of the lithium ion and lithium polymer itself only come out with 3.7 volt, while the regulator from the power bank make it a 5 volt. This affected the discharging, and the discharging take about a hour to make the percentage of the battery span is being decreases. But this decreasing of discharging, we will go into the smart trolley, and we can see when the uses of the discharging is more, then there are more lot of what we can see the power will be consumed. So this make the power bank is less long lasting than the other one. So this is we conclude inside the lithium polymer itself. So my methodology for this project is how to this process will be taken. Yes, we have to make literature review on the researcher on this type of battery, the battery itself characteristic, how to the lithium ion, lithium polymer, base chemical of their type to make it as discharge, and discharge the what we can mechanism. So the third is hardware development, when I have to manage to combine all the hardware, the Raspberry Pi, the Arduino, the barcode, the scanner, the infrared sensor, and the LED, and for the power bank itself. So after that, I will have to make a software development. That means after I have to try it for the software to make sure the software is running correctly, follow the program that I have set up, and then after that, if it's good and can functioning, so I will go to make it connect with the voltmeter and the power bank to record the data. In this time, there are a lot of things that we must consider, because they are a factor of the tools that we use for the voltmeter and the multimeter. So the better is every regeneration, but for me it's about my house cannot have the regenerator because it's quite expensive. So I try to make less cheaper for me to analyze the data. So that's all for my methodology. So as you can see, this is the first of the product of the smart trolley. This is 3 sensor at here, here, and here. This is a barcode scanner. This is all the system that I will take on the box, the Raspberry Pi, Arduino, and the system itself. So for my conclusion and recommendation, this personnel is good, as well as I have asked for many people that they said that this is a good item that we should have in a shopping mall. And also with the existing of the infrared sensor can help many more people. So as we can see, for the recommendation, we can use tool that eventually can make more analysis for the battery to make sure the correct, and to make sure the sustainability and efficiency more on the battery itself. And we can plus add any of the other functioning things to our smart trolley. Hi, today we will introduce with our product. So this is how we connect the power source with the trolley. first of all, find about 5 voltage and 2.1 ampere like this, so that we just connect it with the USB cable and plug it, so that our product Smart Trolley will gain the power to functioning. So here, as we can see, this our product use Windows IoT to make this Raspberry Pi and Arduino functioning with the battery from power bank. That is the Windows logo for our functioning project. Then after a while, there will be a box will come out, and our interface will be shown. So this is our first thing we will see in our project. We will take a walk and look for the function of our infrared sensor. So this is where we can see when the sensor being detected to the obstacle, so that the LED will be light on and our user can avoid any obstacle in front of it. After that, as we can see, this is our first interface that consists our main programming. So this we can see there are create product, view my cart, set budget and reset cart. Also there are add to cart, and we can see the item in cart and the budget we want to inside this project. So we name it as barcode system, that we can use all this feature in our program. So let's set our budget. So first budget we will add about 60 ringgit. Let's try it, 60 ringgit. So if we false in item, so we can reset it and we'll input it again, 60 ringgit. So after that we save it. Now we can see here their budget. Next, we will scan our first product, that is our product. So this is the title, barcode. Here is a description about the product, the same as the product inside the box. So we can ensure this product is correct, and then we can add to cart. So here we can see they added to cart, and we see they are priced on the top, same as the below. So we add a next item, we scan it, and there are same, the title, the barcode, the description, and make sure the picture is same. Then we add to cart. So as we can see, the price is 11 ringgit 50 cent, and it's added with our previous item that become 21 ringgit 30 cent. So let's proceed. Next item. So same, we add to the cart, we check the price. Still in our budget, so we will continue to buy another thing. Scan it, add, same, add to cart. So the price budget is not limit, so we can add more of our product. So let's continue our journey. Scan it, add to cart. Same process, we do it repeatedly until we can observe that the price become orange color, that show our budget is nearly reach the limit. So we can be careful to spend our money, and we continue to buy a thing. Here, as we can see, the price budget has been raised. It's about 17.30 cents. There already reach our limit budget. So here we can view my cart, look at our items that we want to buy, and choose what item we want to delete to make sure we don't limit our budget. So press the next button, choose the item, and press the delete. So we back and see that there is still red color for our price. So view our card again and choose again and delete until our price is below our budget, so that the price color become orange again, so we can start to pay. Here our voltmeter, our lithium ion power bank, and our lithium polymer power bank. So here we will see how we make the analysis of the milliampere per hour with our power bank. That's it, how we connect it between the power bank of 5 volt and 2.1 ampere output to our system Raspberry and Arduino. And we must make sure the voltmeter is connected correctly and can be used. On the voltmeter, we can see the current flow, the voltage flow, and the milliampere per hour for this project. So that we take out the result and make an analysis for our discharging.